Okay, for working backwards, we get the z value from the area that given. So the area under the curve that given, we want to find the value of the z value, right? So here question is find the value of z that has an area of 0.05 to its right. So this is the middle 0. So to its right. So to its right means the right part, not the left part. Okay, so 0.05. So normally from the table we can only get the probability which is below. So we just simply 1 minus the probability that given. So minus it we will get 0.95. So 0.95. So we now only can refer the table. If not, we cannot refer. So we will find the z value. So here it's in between these two values, right, between these two values. So we choose the set that is halfway between 1.64 and also 1.65. So we just plus simply and divide it, we will get 1.645. So it seems it because it's between. So now how we want to choose the z value. So we see this probability and see the z value on the left and also on the top. So here is 1.64 and 1.65. So just simply divided by plus and divided by 2, we will get the z value. So this is how we want to determine the z value from probability. Okay, so to find an area for a normal random variable x with the mean mu and also the standard deviation sigma, we standardize or rescale, right? Okay, so this is an example that we how we want to standardize. So the z, if they tell example the question is find the probability x greater than 7 and the information are given without standardizing, which is mu is 5 and sigma is 2, so we must standardize it. Probability of x is greater than 7, so we standardize x to the z. Okay, so 7 minus the mu divided by the sigma, we will get probability z greater than 1. Okay, greater than 1. So how we want to identify greater than 1? So we want minus the probability of the z less than 1. So we see the table and we will get the probability of greater than 1. Okay. So 0.1587 lah. Okay. This is another example. So which is we will find the z value. So the probability given here is 0.01. Okay, 0. Only will exceed the weightage. So this 0.01 will exceed. So we want to find the z value, right? We don't know how much the z value. So actually here they given already the mean is 1 and also the sigma is 0.1. So we want to find the x value. So from the probability given 0.01 is greater because they tell the weightage of package such that 0.01 will exceed this weight. So exceed, not below. So from the table we only can get the below information. So we just simply 1 minus the below, if more easy 1 minus the below, z less than this value, so we will minus it with 1. So when 1 minus with the 0.01, we will get 0.99. So from this 0.99 we find the z value, so we will get 2.33 from the statistical table. So we can find the x value because they're asking the weight. So we can get the x value, just simply shift over, we will get 1.233. So how to approximate the binomial? So for approximate binomial, we we will have to do continuity correlation, which is z equals to x minus the np, which is the mean for the binomial distribution, and also divided by the square root of npq, which is the standard deviation for the binomial distribution. So this is the way to standardize the value of x for the binomial distribution. So, and we will have to make sure that np and also nq are greater than 5, so to avoid the inaccurate approximation. So to approximate to the normal from binomial, we have to make sure that np and nq is greater than 5. Okay, so this is one of the example which uses binomial distribution to approximate to the normal. So we want to find the x which is less than equals to 10, since it's very big. Another thing, we also must make sure the data in the binomial is less than equals to 25. So this question, so the n is greater and equals to 25. So it must be greater, cannot be below, because we want to use for the normal. So the normal is a very large quantity, we can find for the very large quantity. So the n is must be greater than equals to 25. So here from the question, they given n and also the probability p, the success. So we need to identify the failure probability, which is 0.6 and 0.4 for the success. So we find the mean and also the we have to find the mean and also the standard deviation. But before that, we have to see whether the normal approximation is can be done or not. So we find the np and also nq. So since it's greater than 5, we can continue for the normal distribution calculation. So the mean will be np, calculate, can get this, and the sigma is the standard deviation, we will get the 2.683. So we want to find the probability of x which is less than equals to 10. So we have to plus with the 0.5, because since this is the not the normal distribution value, it's a binomial, which is a whole number. It can't be a decimal point. So for the normal approximation, we add 0.5. So we will get 10.5 minus with the mean and also standard deviation. We will get the z value, and we just simply find the probability from the table. So that's all for the explanation of the normal distribution. Thank you.